Hello and welcome back. Once again, we need to find a limit using L'Hopital's rule. And once again, you have to check that form before you apply the rule. So let's take a look at the form for this particular function, or this limit, I should say. And so as x goes to infinity, obviously x goes to infinity, and 1 over x goes to 0, and the sign of 0 is 0. So this is the form of infinity times 0. And again, this is not an indeterminate form. So what we have to do is we have to rewrite this limit problem so that we can actually have an indeterminate form and apply L'Hopital's rule. So to find this limit, what we're going to do is a little bit of an algebraic rewrite. We're going to leave the sign of 1 over x in the numerator. But for our denominator, we're going to rewrite the x that we're multiplying by as division by 1 over x. A quick multiplication by reciprocal shows that these two things are exactly the same. But what's important now is taking a look at this form. This form is actually going to be 0 over 0 since x is going to infinity and the fraction 1 over x goes to 0. So we are now ready for L'Hopital's rule. So in doing so, we're going to take a look at the limit of the ratio of the two derivatives. So the derivative of the sine of 1 over x, well, that is the cosine of 1 over x times a negative 1 over x squared by our chain rule. And then down below, derivative of 1 over x is negative 1 over x squared again. All right, so that right there is the application of L'Hopital's rule. And you will notice that these negative 1 over x squared quantities will cancel out algebraically. So we're left with just the limit as x goes to infinity of the cosine of 1 over x. And we now need to use the rule for composition of functions. We can now take this and rewrite it as the cosine of the limit as x goes to infinity of 1 over x, because cosine is a continuous function. And now we can actually take that limit as the cosine, and the limit as x goes to infinity, 1 over x, we know is 0. So this is the cosine of 0, which is 1. So we found that the limit of our original function is equal to 1. And again, you will notice again that we had to use L'Hopital's rule with an algebraic rewrite to get our hands on that value at the end.